Hi class, this is Mrs. Lyons. The purpose of this video is to explain atomic size, which is also referred to as atomic radius. So whether we use the word size or radius, basically what this trend is the size of the atom, okay? And the size of the atom is affected by the outermost energy level. So by that valence energy level. Okay, so that's what we're going to look at, and we're going to determine what effect the valence shell has on the size of the atom. Okay, so the first trend we're going to talk about is the trend of going down a group. Okay, so I've taken what we see here are the elements in the first group on the periodic table: lithium, sodium, potassium. Now, we know that elements in the same group have the same number of valence electrons. So sodium, lithium, and potassium all have one electron in their outermost energy level. So that doesn't change. So that will not explain to us, why the size changes. And what happens to the size is it increases as you go down. Okay, so lithium, so what we're looking at is what changes as you go from lithium to sodium to potassium. And if we use our Bohr models, what we can see is lithium has 2 energy levels. Sodium has 3 energy levels. And potassium, has 4 energy levels. Okay, so that makes sense. As we go from lithium to sodium to potassium, we can actually visualize the atom getting bigger because we're adding more levels of electrons. Okay, so that one is relatively straightforward. But we also need to talk about what happens as we go from left to right across a period. Okay, and this trend isn't necessarily obvious. It's a little bit harder to explain because what happens is as you move across a period, the atoms get smaller. Okay, so why is that true? Well, if we look at elements in period 2, so lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, what we see is the number of valence electrons does not stay the same. Okay, lithium has 1 valence electron, beryllium has 2, boron has 3, carbon has 4. Okay, all the way until we get over here to fluorine, which has 7 valence electrons. So that, why does that make the atom bigger? We're adding 1 electron, but we're also adding 1 proton. So we would think it would make the atom bigger. It doesn't make the atom bigger. The atom is smaller. And the reason for that is because of the number of protons and the degree of positive charge in the nucleus of the atom. Okay, so as you're moving across the period, with each element, you add a proton. Yes, you add an electron also, but it's in the same energy level. So basically, it's the same distance from the nucleus. Well, we know opposites attract, right? So as you move across and you add an additional proton, the positive charge of the nucleus gets stronger. Okay, so I want you to think of like a tug of war between the nucleus and the valence electrons. Okay, so in lithium, there's a positive 3 charge, and that positive 3 charge is going to pull on the valence electrons. It's going to pull the valence electrons towards the nucleus. Okay, as we get to beryllium, beryllium has 4 protons, so it's got an additional positive charge that is pulling those valence electrons, so it can pull them a little bit stronger. If we get all the way over here to fluorine, fluorine has 9 electrons in the nucleus, okay? And what that means is fluorine has a lot of positive in the nucleus, and that's a very strong pull towards those valence electrons. And what happens as you go from left to right is the atom actually gets smaller because the valence electrons are more strongly attracted to the positive protons in the nucleus. Okay, so in terms of atomic radius or atomic size, okay, as you go down a group, the size increases. As you go left to right across a period, the size decreases. Okay, increases because of more energy levels, decreases across because there's more positive charge in the nucleus and a stronger attraction to the electrons. Okay, so hopefully that helps explain a little bit this idea of atomic radius and what happens as we go down a group or across a period.